Hello all, welcome back. Now over here in previous video we left over here, right, where we saw the importance of each of the feature provided by logistic regression, random forest and XGBoost. Now what I'm going to do is I will not get into the elimination of the features at this point of time because my model is already trained. So at this point of time I'm thinking not to go back and drop the features and then again try to train the models, because each of the model has its own specification and requirement. So I'm thinking generalizing the set of features for all of the models would not be appropriate at this point of time. So if you choose to go with XGB in your real job, if you present this kind of analysis and if the stakeholders chooses either of the model, considering the provided accuracy also, if the stakeholders chooses either of the model, what you can do is according to that model you can go ahead and drop the features which are contributing less, and you can continue with the features which are contributing more, and then you can again train your model and you can conclude that. So over here I'm going to keep all the three predictions at this point of time, but what I'm going to do is I will combine this prediction with my original data. So the original data, when I say that, means just before, when we started with treating the categorical columns, right? I mean the point when we finished cleaning of our numerical values. So if you would see over here, categorical features treatment, just before that into this data we were done with imputing the missing values and removing outliers, etc. So in this data, whatever prediction we made with logistic regression, random forest and XGBoost, all of those three predictions I'm going to combine with this data. Okay, credit credit data, this is the data which I'm going to use to combine all of those prediction with, concatenate all of those prediction with. Rather I would use this one, this is the copy of that. Okay, in this one. Now before I start with combining the things, what we have to understand is the shape of the data. You see, this particular data was imbalanced, right? They, after having this data, the operations which we performed, we did the one hot encoding, which is get dummies, right? That will not create much difference in the dimension of the data, that is okay. But when we are trying to put the prediction in, then we are trying to put the prediction in absolutely original data, where this is not treated in one hot encoding, because this is what will make sense to your senior management. They will not understand 0 1 etc for all of those features. So it is always important to keep it in more practical format. Okay, so this is what your senior management will understand, that this is type of the loan. If you put it in one hot encoded format, they will not understand. So that's where I'm going to do it. I'm going to bring my prediction into this particular data frame. So what we have to understand is the shape of this particular data frame was different. What we did is we took this, then we did one hot encoding. That will also not change the shape of the data. We did a scaling, that will also not change the shape of the data. But we did smooth balancing, the data balancing with smooth, and over there we had observed that the balancing act had increased the number of observation, number of records, right? You see over here that has increased the number of records. So in that case, how would the merging will happen? That's something I'm going to explain you with the help of an example. So consider this is our original data just before we started treating the categorical column. Now in this, what you see is 7 records are, I mean I've just taken hypothetical numbers just for the understanding. In this data set we have 10 records, out of which 7 are negative and 3 are positive. Now when we do the balancing, so when we were doing the balancing, what it did was it created some more synthetic data for the minority class to make it equivalent to the majority class. So in majority class we had 7 records, and in minority class we had 3 records only. So smooth balancing, what it did is it created 4 more records to make it equivalent to the majority class. Now we have majority also with 7, and minority, uh, which previously was minority, now it is not minority anymore. Now this also has 7 records, and the indices were added onto it. So now what you should notice is the balancing act did not made any change in the already existing records. What it did is it created some synthetic data and it appended into that. So this indices corresponding to its original data remains same, no changes has been made into it. Okay, so that's something which which you should notice. So you might notice that I have, while explaining this part, I have skipped the scaling. Why? Because scaling had not created any difference in our data, but when we are merging prediction with our original back with our data, we are not going to merge with the scale data, because the scale data is not making much sense, uh, is not something in the format which senior management can understand. So that's where we have to merge it with very original data, which was this, which has the actual name of the products and everything, right? So that's something which you should notice. Just ignore the scaling part while we are talking about this merging. Focus on the original data. Come to the balancing part. So in the balancing, what we saw is this number of records have been created. Now think about the training, when we did the train test split training data, right? In training data, what had happened, whatever data we created after smooth, out of that 80% were placed into the training and 20% were placed for testing. For example, let's take this one. Okay, so into this, what might have happened is, in while doing the train test split, this is what might have happened. Okay, let's say this is the split which has happened. Okay, this, and let's take again this over here, right? And this again over here. How many records are this? Are these 7? Let's put one more over here. So I have not taken exactly the 30, exactly 80%. It's just consider I'm creating an hypothesis. So that's where I need you to just understand that this is approximately 80% of the records. Okay. Now the remaining records we had in test. So in test, what we might have had is this. Then let me just quickly do this part so that we will get the list very, very quickly. I will just exclude this. Okay, so all of these records are something which we would have over here in the test part. Okay, this. Now let me just delete this. So these were the test and these were the training. Now just 1 second, I'll bring it down one more, and then this is how it is. Okay, now when we did the prediction was done for this set of data only, right? Prediction was done for this part. So over here you see pred outcome. So this is what, let's say in prediction we might have got this, right? This, and then 0, then this. Okay, so this is something which we would have got. Now in the prediction we have only this thing, right? Now how to merge this with this one? We have to merge this thing with this one. So remember, what Python does is Python never alters the indices. It never does any alteration in the indices number. Okay, index numbering, it never makes any alteration. So whatever prediction that we have for this, what we will do is we will map this prediction against these indices which we have in our test data. So we will make it something like this. So you see, this is the original defaulters flag, and this is the predicted defaulters flag. Okay, don't get into the accuracy and exact number, let's just consider it as of now. And this was the index. Okay, now once we have this prediction mapped with this test data indices, what we can do is, now we can basis on this indices we can directly merge with our original data, something like this. Over here we will do this, and we will come back over here and we look up, and the output which we will have is something like this. So you see, wherever we have hash NA, that means those were not considered, those were not part of the test data. That's why we don't have it. So we would have the prediction available for only those records which were part of the test data. And this is how we can come up with the prediction in our original data set. So we would require, when we are presenting, we would require to exclude this while we are presenting, and we would require to include these observations only in our presentation. So I just hope that it was clear to you. In case of any doubt, put that into the comment section. So this is exactly what we are going to do. We have this prediction from 3 models. For each of the prediction, we are going to add it with the indices and then merge that back with the original data frame. Okay, so let's just get back to this work. All right, so first thing which we are going to do is, we have 3 predictions. Okay, uh, where we have the predictions stored. Predict XGB prediction. So we have XGB predictions available. Let's start with XGB prediction. XGB prediction. Okay, so we need, so currently what we have is this array. We need to convert it, like, we have to convert it in the form of data frame. So what we are going to do is, I would say pd dot data frame, and inside this I'm going to say, let's just say, let me just cut it for now. And over here what we require to, first I'm going to say test, or test indices. So test indices which we had was in x test dot index. So from here I will take the indices and I'll put it inside this. Then the next one which I'm going to do is xgb prediction, xgb prediction, and over here this prediction goes in, and I'm going to enclose this in the parenthesis operator, and here I'm going to say xgb prediction df. This is what the data frame I'm going to create, and let's just have a look on this. Wow, we got it right. So these are the indices, and this is the xgb prediction. Okay, now the next thing which we are going to do is, same thing we will repeat for each of the models. Okay, now let's say logit prediction underscore df, and after that I'm going to use this one, and over here what I'll do is I'll take this and I'll just put it over here. This is logistic regression prediction, and then there is one more which we need to put, that is random forest, rf dot prediction underscore df, and this is what I'm going to do, this, and over here this. All right, this is done. All of the 3 things have been created. Now after this we need to do the merging. We need to merge this with original data frame. So the original data frame name was this, cr data copy. So I'm going to do this, cr data copy dot merge. Before that I'll create a copy of this, merged with original. Okay, and over here I'm going to say this, comma merge. Inside this, one by one we will do the merging. xgb prediction df, comma. Now when we are doing the merge, so from this I want to take the indexes in these three. Okay, in these 3 predictions we have 2 columns. First column is for indices, second column is for this thing. Here I'm going to say, let me just name it something like xgb, and so that I could differentiate it at the time of dropping, rf and then over here I'm going to say lock it. Okay, now if I have to display it, so I think that should be pretty simple. You see over here we got test lock it, then we see this one, we have this rf, and then this one. So pretty simple. Okay, now after this what I'm going to say is index left index equals to true. So what I'm saying is simple. From this data frame I'm asking that you take the index column, index as the key column to make the join, and here from the right hand side, right index, first of all I'm going to join with xgb model, xgb predictions. Okay, so from here I will take this one. This is done, and how I want to do the merge, I want to do it left merge, left, and let's just see how it looks. Okay, there seem to be some issue. Left is not different. Okay, I need to put it in quotations. Now what's the problem? Right index parameter must be of type boolean. Why? No, this is here I need to say right on. Okay, this is done. Now you see over here it says NaN, which means our left hand data side do not have a record for this one. Okay, I mean there is no record available in xgb pred for this original record, so that's why we are saying NaN. You remember this part, okay, where we don't have the match, we will get NaN. So I think that is pretty much fine. Next joining again we are going to do on top of this. So I'm trying to keep it simple, that's why I'm doing the joining in multiple form. Okay, and over here I'm going to say merged with, next one I'm going to merge with random forest. Okay, now I will take this whole data from here, and inside of instead of this I would consider this data frame. All right, and over here what I'll do is I will use rf prediction df, and let's just see how it looks. Now in this data, one thing you should notice is this part. Okay, indices, this is something which I would be dropping at the end, not now. Okay, and let's just see how it looks. Dot head. Again there, oops, here I need to say rf. We got this one merged. xgb pred y, why is this saying xgb pred y, xgb prediction x? There seems to be something wrong. Why it would have xgb prediction twice? I don't think it should have the xgb prediction twice. Merged with rf prediction df, merged with xgb pred, merged with the original. This is what I'm choosing over here. Test indices xgb pred, test indices rf, xgb pred y. Okay, I think there is some problem while I was creating this data frame. Over here you see this is something which I did wrong. Here I should say rf, and here I should say lock it. So that's a silly mistake which I had made, and now you see how it can cost you the double effort. Right, now this is done. Next one again I'm going to do the next merge, and this time I'm going to do the merge, I'm going to say it final, and over here I will use this data frame. All right, and over here I'm going to use lock it prediction data frame. Okay, and over here what is the one that we would be having? Right on rf, and here I think it will be lock it. lock it. I think this is what I had written over here. Yeah, this one. This is what I had over here, and now I'm going to see this final. This is done. Oh god, this is looking more pathetic. I don't know. Okay, now this is done. Let's just try to check the shape of this data. Dot shape. So you see, you remember this was the original number of records which we had in our original data frame. Let me try to see if it is printed somewhere at the top side. It must be, certainly. Yeah, you see over here, scaled TF we had 31,671. So into that we have got this merge. Next thing which I'm going to do is I'm going to drop the null values. Okay, so drop this. Is there something which is called drop NA? Drop NA, and let's just see what happens. That is done, and we are left with just 217 rows. So this would have dropped negative blank values wherever it was null in either of the columns. So all of them has been dropped. Okay, so this is how it has been merged. Now we are left with 273 rows, and that's what we are going to utilize in our presentation. Now we got the prediction for 273, right? Now don't think that after putting so much of the effort we got the prediction for only 273 records only, because you know, over here there are multiple steps taken in balancing and all those parts, right? So if you now once your model is trained, what you can do is you can again take the original data and you can put into the procedure and you can get the prediction on whole data, and then you can merge that. So you don't have to worry about it. It is just a sample. So if it is needed, what we can do is we can take the whole this whole data set, this one. We can do the treatment, all the necessary treatments, which includes one hot and all those sort of cleaning work. And after doing that cleaning work, this time we don't need to I mean, we can of course do the scaling of the data. Okay, and and we can this time when once your model is trained, you don't need to do the balancing again, because that once model is trained, of course you will be using that on unseen data. So you just do the scaling, and after doing the scaling you can directly use that into the prediction. So next time when we do the prediction, we would have this thing available for whole set of data, which we will also try. But for now what I'm going to do is I'm going to be focusing on this part of the data only, right? But I highly encourage you, what you do is I mean, after once completing this analysis, we will automate this process, right? And after automating this process, I would encourage you to use that module on whole set of data and try to create the prediction. We will also try to do that, but for now let's continue with this 273 records. Okay, now I'm going to take this 273. Let's just have a view on this loan status. Okay, we need to do one more thing, and let me just see if what is this thing that we got over here. Okay, here it is giving us the whole data set. So here what we need to do is we need to say in place equals to true. In place equals to true. Okay, now if you see over here, it will always give us 273. This is done. If you want to see the head of the data, this is it. And if you want to see the shape, that will of course be available, which we just observed. Now out of this, I also need to drop these three things, this, and this. These three things I need to drop. So after this, I'm going to say drop this set of columns, because this does not have any value addition in my final analysis. This is XGB prediction. I'm going to keep that. Then next one is this, And after this, what I will do is I'll drop this data frame also, sorry, not data frame, but the column. Okay, and axis equals to 1. I'm going to say final data with prediction. Okay, and let's just say head. There is one more mistake which I was going to do, and this is this. Okay, now let's just see this is final. After this, I'm going to export this into Excel, to Excel, and where I'm going to keep my Excel is in here. And for that, this is what I need to do, and over here I say pd prediction dot xlsx, and here I would say index equals to false, so that it does not give me the index in the final data. I don't require that. Okay, pd prediction, this is what we got. It's opening up, don't worry. So here is the data we got, and let's just try to compare. Okay, loan status is this. I'm going to take this and put it right over here so that we could do the comparison. Now this loan status looks pretty much in alignment with XGB model, and less with pretty much with XGB model, and less with this ref prediction and logit prediction. Let me try to freeze pan, and you see over here very well. XGB model is doing pretty well. You see, this was the true where it has made the mistake, but overall it is doing pretty well, isn't it? And you see this RF prediction, which means random forest, this is doing relatively this is doing better than logistic regression. Okay, which was apparently clear when we were making the models. Okay, so now you see over here, this is also good. Here model has made the incorrect prediction, but XGB has done the correct prediction, but these two have made incorrect prediction. So you see how good the prediction was now. So this is done. Now I'm going to take this into the Power BI, and after bringing that into Power BI, we are going to make some analysis and see how the things has worked upon. Let's just try to put it over here. It's just taking few moment, and after that we would have this data available in Power BI, and then after that we will make the presentations on top of this. Okay, let's just have it very quickly. Now I know the data, the video is becoming little big. I mean, not little, but it's quite big, to be honest, right? Quite long video, and you can say lengthy also. But trust me, this is going to give you a significant amount of confidence, right? And you will be pretty confident in making the model. What are the steps that you should take? So be with me, and after doing the analysis, we will summarize all of the things, what are the steps that we took, and everything we will do end to end. So over here, let's just have the data imported, and once the data is imported, we will start creating the visualizations for that, which can be further presented to the senior management team and all. Okay, so mostly we will try to put it in the form of line chart, where we could do the comparison with all of these four things. Why I'm saying the original target and then the prediction from three models, we would be able to compare it, how was that performing. Okay, now I think we have our data available over here. Now the time comes when we need to create the visualization. I think the video is becoming a little longer, so I'll pause over here, and then in the next one we will start with creating the visualization.